All right, today we are going to go over another example of inheritance. It is an important topic, and we want to make sure that you have it down. I don't know how long that will go. Depending on how long it goes, we'll decide what to do next. Okay. Let's say we have an organization that has sales reps, and it has three kinds of sales rep. It has your ordinary sales rep, your typical default sales rep, and then it has a junior sales rep, and then it has a senior sales rep. Now, what I'm going to show, there are possibly other ways to do it, and I'll talk about the other ways that we could do it later on after we go over this view. But the way that I did this is I created a class for sales rep to be sort of the base class, and had junior sales rep and senior sales rep both inherit from the sales rep class. So let's look at the sales rep class. For our purposes, and keep in mind that I aim to keep these examples fairly simple, so an actual application, there would be many more attributes and methods in this, but I just want to show some concepts here. Sales rep has three attributes: employee ID, name, and sales amount. The employee has, or the sales rep has, a constructor that accepts those three attributes: employee ID, argument for name, and argument for sales amounts. And those get set by the arguments that get passed in. Notice that this calls the set method. In our first few examples, we might have done something like this. Now, what is wrong with that? Well, what's wrong with that is that we may later on at some point have validation code. Maybe the employee ID has to be a number that has at least 6 digits in it, for example. So if we try to create an employee with more than 6 digits or less than 6 digits, there would be some kind of error. All right. When we review exceptions, we'll look at those kinds of things. Likewise, name, name can't be an empty string. Set sales amount to sales amount couldn't be a negative amount. Couldn't be probably more than a certain maximum amount. So we're going to put eventually those constraints here. In the set method. And if in our constructor we call the set method, like we're doing here, that error checking happens. Whereas if we simply say employee ID equals arg employee ID, that error checking would not get done. Now you might say, well, why can't I just put the error checking up here? Well, you can, but you're going to violate one of the key principles of programming. I'm going to make this as big a font as I possibly can. Only goes up to 72. Darn. DRY. DRY is an acronym for don't repeat yourself. What is wrong with repeating yourself? Well, if you repeat yourself, there's a chance that you might have, and by repeating yourself, I mean having duplicate code. So if we had validation here, as well as in here, I'd be repeating the validation. There's a chance that you're not going to exactly duplicate it. That someone later on, when they go and change the program, they might change it in one place and forget to do the other place. All right. If the code's only in one place, then it's going to be consistent. All right. And if it's wrong, there's only one place to fix it. So much of what we do in programming is based on what makes the program easier to maintain. That is, to make changes to the program. Because it doesn't matter what technology you're using, what programming language or platform or whatever that you're using. A universal truth is that at some point you're going to need to change the application. All right. And code that is designed with it in mind to keep it easy to change is better than code where it is harder to change. I had a couple people, for example, have a series of if statements or a case statement that looked at the number of credit hours. And if the credit hours were 19, then the tuition was this much. If the credit hours were 20, the tuition was this much, and so on. What's wrong with that is if the college changes tuition policy, you'd have to change all of those different places. Whereas if you do it in a clever way, if the college changed its tuition policy, you would really only have to make the change in one place. All right, so do not repeat yourself. So therefore, again, at this point, it might not be clear, and you might think that the two ways are equal, but when we add to the fact that later on we're going to have validation and error checking here, then it becomes a key issue. We have all our sets, we have all our gets. Remember, your variables should be private or protected. Private means that only within this class can that variable be accessed. Protected means this class and any of its subclasses. Now, there's people that would argue that they should all be private and you use methods in the subclasses, but I'm not going to take it that far. That makes it a little confusing, in my humble opinion. We have gets for them as well. Now, we then have calculate to a commission, which is 10% of the sales. Calculate their base salary, which is $2,000, and finally get their total salary, which is the base salary plus the commission. So this is true for your typical sales rep, your sort of default ordinary sales rep. Now, some people did something like this, and this is not correct, but just note this. Some people did something like this. They made an attribute out of commission. And in the constructor, they calculated the value. And you could do this and you could get the right results. And then to get the tuition, get the commission, all you'd have to do is return this variable. What is wrong with that? What's wrong with that is if you went later on after the fact and changed the sales amount, if you notice, for example, you made a typo and you created this object and you changed the sales amount, it would not recalculate the tuition. Well, you might say then put that logic also in the set sales amount. And again, do not repeat yourself. Attributes like commission are, they look like attributes, but they're really what we would call a derived attribute. What do I mean by derived attribute? I mean they can be calculated or determined by looking at some of the other attributes. So I would never declare commission as an attribute. I would instead have a method I even call it get commission. So it kind of looks like an attribute, but it actually does a calculation every time and returns it. To return that derived attribute. You'll see that all over the place in the, in the pizza example, the cost of the pizza was a derived attribute. The bake time for the pizza was a derived attribute. The bake time for an order is a derived attribute. The total cost of the order was a derived attribute. They're things that can be calculated. When someone's subscription expires, it's going to be a calculated attribute. You know the start date, all right? But to determine when the subscription expires, you have to actually do the math and figure it out. And you wouldn't want that to be an attribute because you wouldn't want to have to keep it in sync with the other values, the other attributes. So far, so good. This is pretty straightforward. You know, this is something that we could have done the first week or so of class without too much of a beef here. Now, you notice a toString function. It's sort of a good practice to include a toString function in any class that you develop. There's a default toString function, I believe, on every object because it's inherited. But that isn't terribly useful. In this case, I'm formatting it nicely, and I'll show you an example of that in a few minutes here. This formats it nicely, and it says what this object represents. In other words, this is the object for the sales rep whose name is name. All right, pretty straightforward. If you did that in a student class, you might have, the toString method might say student and display their student ID and then display the name also. You format it whatever way you think is going to be meaningful. And then you can use it to identify an object to give a user-friendly description of what an object represents. Let me peek at the unit test object first. I'm going to comment out everything. We're only going to look at the first test case. So all we're going to look at in this example is the sales rep. I have sales rep. I define as sales rep number 1234. Name is Mike. Sold $5,000 worth of goods. toString should say sales rep Mike. The base salary should be the $2,000. Commission should be 10% of this, so that should be $50. And the total salary should be $500. And the total salary should be $2,500. It's important that you know that, right? You need to know what the right answer is for you to test and validate that your code is right. So I'm going to do this like I might build this for real. If I had to do this job of building these with these classes, I might build a base class and test that out and make sure that that works, and then tackle some of the other things. So let's go to the command prompt. And one thing you can do that saves you typing, if you know that there's only one directory that starts with A, you can do CD A*. All right, we're in there. Let's compile it. And we can run it. And it did as expected. Sales rep Mike, that's the result of the toString function, identifies the object. Base is $2,000. Commission is $5,000. Total is $2,500. So that works. Let me take out the toString function on the student to show you what the default toString function looks like. Sales rep at blah, 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 blah. Okay. What do you think that is? Think for a second what you think that might be. Sales rep is obviously the class that this is. At, the at sign, at, and then it gives a value, a hexadecimal value. What that actually telling you is where the memory location, what the memory location in the Java virtual machine is for this object. Now that's of virtually no use to you. All right, so therefore that's why we overrid it and put in one of our own. Now you might ask, where does this default come from? Well, it's implied that every class that you create inherits from the base Java class, which is called object. If you're going to draw a class diagram in Java, object is at the very top of the peak. Everything inherits from that. All right. And it has a toString function that displays the name of the class and the memory location. But again, that's not terribly useful. Therefore, we write our own to display something that's more meaningful. And we're back to getting a type of class and the name. All right. Now, if you notice in here, I have an Excel spreadsheet that is going to show my test plan. And ideally, you would have this made out prior to you starting coding, right? As soon as you know the rules of what these classes are supposed to do and how much commission and how much the base cost is, price is, or wages and all that, you can actually come up with this. Try to make it bigger here. All right, my scenario, test case number 1 is to test a regular sales rep. So my step to do this is I'm going to create a sales rep object with the sales of $5,000. So either I'm going to use the set or the constructor to set that. What I expect to see is a base of $2,000, commission of $500, a total of $2,500. And what did we actually get? Now I say bug, false. I'd rather think positive. So I'm going to change this. I'm going to change this to say, is this correct? In which case this changes to true. Just to be positive. We wouldn't want to see a bunch of no's in that comment. Well, it might look deceiving. Whereas if we see a bunch of trues in here, we know everything that works. All right, that's one test case. And you're going to build that test case in your unit test. Remember, that's a test object. It's not going to be part of the final system. It's there to do a unit test to test your sales rep objects and make sure that those are correct. Now, you're going to keep that unit test around in case you have to change something. For example, what if we had a third or fourth type of sales rep? Super senior sales rep, all right? It gets paid even more than a senior sales rep. Well, when we do our coding to code the new situation here, we'd add items to the test case, but we wouldn't get rid of these. Why? Because we want to make sure that we didn't screw anything up when we added the new code. Now you might say to yourself, and this would be understandable if you said to yourself, well, look, I'm creating a new class. I'm not even touching those other classes. Why should you have to retest it? And the answer is you have to test it to make sure it still works. All right. You don't know, if I had $1 for every time a junior programmer told me I didn't even touch that code, and when we find out that there's a bug in it. And then when we find out the cause of the bug, it's like, oh yeah, I forgot I made that change as well. All right. Believe me, especially programs that aren't written well can be very fragile, and a change in one place can affect change elsewhere. Now, a well-designed program won't have that problem, but not all programs are well-designed. So therefore, you perform this test, which is called regression testing. So you would keep this around and you would run it through the same test that you did before and make sure that the old stuff still works. So for example, your assignment with the graduate student, all right? You should still test all the conditions that you tested initially for students that are in county, students that are out of county. In other words, do that test for regular students as well, just to make sure that somehow something didn't get changed and introduced a bug into the system. Writing software is tough. If you think that, the code rewrite are small potatoes, right? You imagine an operating system or a major application or a game, there's thousands of instructions, millions probably. All right. And it's easy for something to go wrong. And it's easy for something to go wrong based on some situation. In other words, a program that's incorrect isn't going to be a program that blows up every single time you run it. More than likely, it's going to be a program that produces bad results under some particular set of circumstances. And therefore, we want to cast as wide a net as possible and test as much as we possibly can to make sure that we've caught those errors. And if we make a change, we want to do regression test and test it over. Now, that's the first test. And I literally put in my test code, I have my test plan with my test cases, and I literally put in my unit test case 1, and what I expect the results should be. Okay, now let's look at these other 2 classes. We have a junior sales rep and a senior sales rep. Let's look at what they contain. Now remember, you don't have to repeat anything that is in the student class other than constructors. Constructors don't inherit. So a subclass does not get inherited. The superclass is constructors. You still have to define constructors on the subclass. So I'll open up this one. And I'll open up this one. Now, what's different? And I already hinted at this. What's the difference between a junior sales rep and a senior sales rep? Well, they have the same attributes. But what's going to be different is the calculation of commission, the calculation of the base salary. Is this going to be any different? Actually not. We're going to calculate the commission and base salary a different way, but the total salary is still going to be the sum of the base salary plus the commissions. And finally, the to string is going to be different because I want to define that these are senior sales reps or junior sales reps. Now, what I would expect to have in those classes then would be a constructor, probably the same constructor as the sales rep because a senior sales rep has the same attributes as a regular sales rep, and so does a junior sales rep. So I'd expect a constructor. I'd expect calculate base or get base, get commission, and to string. Sure enough, that's what I have. There's my constructor. Immediately it calls the super classes constructor and passes the same arguments. Constructor chaining, that goes up the line. If this wasn't here, I eliminated this, what would happen when I tried to compile it? When I tried to compile it, junior sales rep has no constructors. Therefore, it would call, oh, did you have a question or did you want to answer? Okay. Junior sales rep has no constructors. Therefore, the default no argument constructor would get called. That would call, in turn, the default no argument constructor on the sales rep, which the sales rep doesn't have because we've defined a function constructor on that level. So if we did this, we're going to get an error on junior sales rep. In fact, let's go and do that. This is telling me, hey, there's a problem. We require no arguments for the junior sales rep, and we're giving some arguments. Well, let's go and change the unit test to not give any arguments, see if that will fix it. It's telling me there's a constructor and sales rep because sales rep effectively has no argument constructor. It has a constructor that expects these things. Let me go, and I hope I can undo the changes I made to get back to where we want to be so we can compile.
Question, sir. Can you hear me? Shoot, you can't hear me.
Forgot to save.
Testing.
All right.
Testing. Can you hear me?
Senior sales rep, same idea, except this has a different way of calculating commission. This one, they get an extra bonus if
Testing.
commission is more than, if the sales amount is more than $10,000, they get an extra 2.5%. So they start off with 12.5% and a bonus 2.5% for the amount over $10,000. And the two string is different.
I have a quick question, sir.
So we look at our unit test, and we have a test case where we set this, test case where we set this, and that corresponds to the test case we have here. And it should give us that amount. So we're going to go and run these, get the actual amount, and we're going to update our test plan. Junior sales rep should get paid $1,800, and the senior sales rep should get paid $3,500. Correct and correct. So we would update the actual and we would put true here and here. Now, did I thoroughly test this? Unfortunately not. I'm missing a situation that could be wrong. All right? Because for a regular sales rep and a junior sales rep, their calculation is straightforward. It's a certain percent of their sales. But with the senior sales rep, if they sell above $10,000, they get an extra bonus. They get an extra 2.5%. So I could have a bug in here. What I really need to do is have another test case in here. Senior sales rep less than 10,000 sales. Senior sales rep greater than 10,000 sales. Let's make the sales 11,000. Gonna make me do math here, huh? 2,500 is their base salary plus 10% of 1,100 would be of 11,000. I mean, would be 1,100 plus 2.5% of the amount over that, which is 1,000 over it. 2.5% of 1,000 is 25, I think. So their total should be 3625. We'll see if that's correct. We'll go in and add another test case. How do you know what, how do you remember, or how do you think of all these test cases? Look to where there's branching statements. Look to where two different things can happen. Here's the thing where two different things can happen. So you need to have two test cases to handle that. you can see based on that notion, you could get a lot of test cases really quickly, but that's the cost of getting good results. So I'm going to put test case.
I have a question, sir. Can you hear me?
Ignore this code for a second.
Can't think it.
We'll come back to that.
Can you hear me now? This thing does not like me. Testing.
$3,900 for that sales rep. Wow. Commission's $1,400. Oh yeah, the commission isn't, I forgot, the commission is 12.5% of 10,000. So let me get out my calculator.
Do you hear me, sir?
I mean, that's a possibility too. Maybe your program's better than your math. So 11,000 times
Oh, you can hear me. I don't think you can hear me.
0.125 is 1375. I was correct with that, and the total sure enough equals 3,700. All right. So now here's an interesting thing. There still could be a bug in this, right? Oh, okay, 1 second, Phil. There still could be a bug on this. What if this code was incorrect and this code was looking for, instead of looking for greater than 10,000, what if the code was had a typo and had a typo here? I said it's greater than 1,100. So sometimes it's good to test right on the border of where the if statement is. Did you have a question, Phil?
Yes, sir, I did. Can you hear me?
I don't know if I can hear you. Could you possibly type it in chat?
Yes, sir. Yes, sir.
How are all the classes connected? Very good. Because both junior sales rep and sales rep extend sales rep. That's how they're connected. In other words, junior and sales, and I should have pointed that out initially, junior and senior sales rep both inherit from the sales rep. So they're subclasses of the sales rep. That's how they're connected. That allows us to not have to define certain functions in the subclass because they're defined in the superclass. Now, if you notice, I threw in an extra function on senior sales rep. that I just said senior sales rep stuff. To just print some information out. Now, if you look at my test class, I'm using polymorphism here. In other words, I'm creating a sales rep. I'm creating a senior sales rep object, but I'm putting a pointer in a pointer that points to sales reps. What does that mean? That means that I can only call functions that are on the sales rep class. But I'm going to get the senior sales rep version of those. So if I try this up here, if I say L senior sales rep stuff, that's defined on the senior sales rep and not on the sales rep, I'm going to get a compile error. Because what we put on this side determines which functions we can call. So we can only call functions that exist on the sales rep class if we do this. Now, what we declare on this side of the equal sign determines what version of those functions we're going to get. So we're going to get the senior sales rep version of those. Now, my workaround for this is I can actually say, all right, I shouldn't have used the letter L. That looks like the number 1, but that is the letter L. That's the variable I created. If L is an instance of, so I'm asking if it's if it belongs to the class of sales rep. If it is, then I'm converting the sales rep object to a senior sales rep object. Now on S, I could call those extra functions. All right, are there any questions? All right, that's all I had for today. I will either see you in lab or we will see you next week.
Can you hear me? Testing. Can you hear me? Can you hear me?
Do you have a question?
Yes, sir. Yes, sir. Testing. Type 2.
Oh, I don't have to type because you can hear me. I just thought of that. You'll join up just like you joined up for this class. Go to the same link. Because I'm going to shut this meeting down and then I'll start a new meeting when I get to lab.
Okay. Okay.
All right? We'll see you in a couple minutes.